Hello and welcome to this AfterMaths episode of the Primary Maths Podcast, the show where we talk all things primary maths. With me, John Cripwell.
And with me, Becky Brown.
Hello, Becky.
John, you have a different surroundings today. I believe you're in the office today.
I am at Twinkle HQ in Sheffield, and it's very nice. There's good coffee and lovely people. And I'm wearing this, if you're watching on YouTube, I'm wearing this very fetching headset and mic combo because I don't have access to my usual microphone and things. But I did think, Becky, as I was waiting for you to join the call, I do look a little bit like, I was going to say Britney Spears in one of her music videos, but maybe not quite like that. One of the ground control people at NASA. Given that, yeah. Given that is going to be kind of the topic of our show today, is the maths behind the space program.
You've brought along props today, John.
Exactly. Yeah, exactly. And we are going to take a little bit, because at the time of recording, just earlier this week, the Artemis 2 program, I guess, capsule landed back in the ocean, and we've yet again sent people around the moon, which is amazing. And I'm sure children in school have been following it and absolutely loving it as well. So we're going to look at a little bit of the maths behind that kind of a journey. And then we're also going to just spend a few minutes talking about one of the pioneers of space-related mathematics, a certain Katherine Johnson, who I know you are familiar with, Becky, because I mentioned this to you earlier, and you said, I know all about her.
Yes, the last class I was teaching in was named after her. So it was year 5, so we did lots of science and space things, and all the classes were named after people who were heavily involved in space science, and Katherine Johnson was ours. So yes, very familiar with Katherine Johnson.
Yeah, it's interesting, isn't it? Class names and things. All of my classes have always just been my year group and my initials. So 6JC, or when I was job sharing for a while with Mrs. Kendall, it was 6JCGK. So I'd never had interesting place names and famous people and things for our classes. I did use them for table groups sometimes.
Yeah.
When we moved away from the red, green, blue, purple tables to try and have more imaginative. But my biggest problem with that was that I could never remember which table was called what. We had famous authors for a bit, and I could never remember who Philip Pullman was. I know who Philip Pullman was. I couldn't remember which table Philip Pullman was.
One of the schools I worked in changed the theme every year. So one year we were all named for historical figures. One year we were all named for musical instruments. One year it was authors, and that was hard to keep track of. I think the office staff particularly were thinking, no, we need year 4 to just be there.
Yes, yeah. And the parents probably too. It's bad enough sometimes when I was in the office at school and we'd have a parent ring in and they'd say, I've forgotten, little Johnny's forgotten his glasses. Can you send a note to his teacher to ask him to sit nearer the front? You're like, yeah, great. Who was his teacher? And they're like, he's in year 3, I think, or year 4. And like, you get it, don't you? Because, if you're not in school, you forget, children, which year groups are which and stuff. But like, come on, the primary school, they have the same teacher all year. Just try and remember that one little detail, maybe. It's different at secondary, when you're trying to remember who the maths teacher is and who their English teacher is and the science teacher.
Secondary parents' evenings were an eye-opener when I first had to go along to those. It's like, okay, I need to know who I'm going to and which subject, and it was all, much more straightforward to go to primary and just sit in one place and talk to one person.
My eldest daughter is in year 8, so we've had 3, I think, secondary parents' evenings now, because they had a settling in one where we actually got to go into school to see form tutor and head of year and things. But all the others have been online now. So you sign up and you have a 5-minute window, and it counts down and it kicks you out after that 5 minutes. But it starts the 5 minutes even before you've joined or before the teacher has joined. So, if the appointment is 5:25, at 5:25, that 5-minute counter starts counting down. So very different from I would say, the majority of primary parents' evenings.
Yeah.
But it did lead to, the combination of that and the fact that these secondary teachers have hundreds of pupils that they might see in a week did mean that in one of the meetings that we had, I won't say with which teacher, after 4 minutes and 30 something seconds, it turned out that they'd been talking about the wrong pupil for those 4 minutes and 30 seconds. And we were getting quite concerned because, it didn't sound like Ellie was doing very well in this. Then it turned out it was the wrong people. But the teacher, to be fair, they apologised and they sent a lovely email with all of the correct information in it. So, these things happen, don't they?
Yeah, exactly. Everyone's only human.
If you have, listeners, any stories of ridiculous classroom names or reprogramming of classroom names or parents' evening shenanigans, we would love to hear from you, wouldn't we, Becky?
Oh, yeah, absolutely. Always lovely to hear listener stories, John.
Yeah, please send them in to primarymathspodcast@twinkle.co.uk or find us on pretty much any of the socials. So, Becky, did you follow the Artemis voyage around the moon much over the last 10 days or so?
I must admit, I followed more the return to Earth than I did. I can't remember why. I knew it was going on, but I hadn't managed to capture what I'm really interested in that sort of thing.
Like, we've been to the moon before, but, coming back from the moon, that's the key bit, isn't it? We can send people out there, that's fine, but can we get them back? That's the main thing.
I know. And that was the bit that was on at like 1 o'clock in the morning or something as well.
Yes.
So why I chose that bit specifically to watch, I don't know. But
I stayed up to watch the launch because I think that's always the kind of exciting bit. And also, God forbid anything goes wrong, but if something's going to go wrong, it's probably going to be at that point. So you want to make sure they get off safely and things, don't they? I was fascinated, the first little bit of maths, I was fascinated by the emergency kind of ejection system that they have it's got a special name, which escapes me right now. But right at the very top of the rocket as it's sat there on the launch pad, just below the top, you've got the capsule where all the astronauts are sat, and then you've got sort of a pointy bit at the top of that, almost like a spike. That's the sort of emergency evacuation system. And if there's a problem with the rocket, it will get the astronauts and their capsule away to safety.
wow.
It goes from 0 to 500 miles an hour in less than a second.
Whoa.
I mean, that is rapid, isn't it?
Yeah.
I assume they pass out at that because the number of Gs that must be involved in that. But better that than, sitting on top of a huge bomb that's exploding beneath you, I suppose.
Yeah. I suppose the idea is they have to get as far away as possible, as quickly as possible. So I guess that's, okay.
Yeah. But that's quite quick.
It's amazing.
That's quite quick. Yeah. So I did stay up to watch that, and then I kind of followed it on the news for the next few days and talked about it with the children and things like that, and they were fascinated with it as well, and obviously very happy to see all four of them come back to Earth and land in the sea or the ocean, I suppose. And I saw a video of them unlocking it. Somebody had to actually have a key to open the outside of the. You wouldn't think a key was necessarily. I mean, who's going to break into it? Well, you'd be concerned, wouldn't you, if you were sort of traveling through space at so many miles per second and somebody knocks on the door or tries the handle. But they opened them up and they went in and opened up the capsule, went in and helped them to leave. One thing that did strike me, a very human part of the story though, Becky, if you've been trapped, if you've been in a small capsule the size of basically a large van for 10 days with 4 people, without showers and with fairly rudimentary toilet systems. Smell that must have greeted the people opening that capsule. They did very well to smile and just, can't have been pleasant. I know they have, systems to wash and things like that. But
that's
still,
a long time though, isn't it? I remember
recycled stale air in there, isn't it? It's obviously all can't be great.
No, I remember watching, and it was years ago now, there was a program which was I guess it was like a reality TV, but it was before reality TV was really a big thing. And it was astronaut training. and things like that. I can't remember the specifics, but it was really interesting, the different things they had to do to be used to certain G-force or being in cramped spaces and so on. It was amazing. I'm going to try to find it, actually.
Yeah. So the original program that took people to the moon in the 1960s and 70s was called Apollo. And this one was called Artemis. Do you know why this one was called Artemis?
I don't know.
So I didn't either, to be fair, but in mythology, Artemis is Apollo's twin sister. So so there's a nice little synchronicity between that. And then also, I found last night a little bit of very, very geeky, nerdy trivia, I'm afraid. One of my favourite films growing up was the original Superman films, 1 and 2 particularly, with Christopher Reeve from the 1978 and 1980. Show my age here. Not that I was born when the first one came out, but anyway. And in the second film of that, there's a storyline, no spoilers here, Becky, but there's a storyline that involves some people on the moon, and the name of their ship is Artemis 2, which it was, I was like, oh yeah, I have heard that before. And obviously the filmmakers there used Artemis for the same reason, that it was closely aligned with Apollo without being Apollo. So it was interesting reading about this, because obviously in the 60s and 70s it was the space race, right? Again, it was the USA against the USSR, Russia as is now. Who can get the first person into space, and then who can get the first man fundamentally onto the moon? And obviously the USSR got the first person into space. Can you remember who that was, Becky? Putting you on the spot here now.
Was it Yuri Gagarin?
Yeah, well done. Yeah, Yuri Gagarin. I think they put the first dog in space as well. Was that Laika or Lion? But then the USA placed the first man, Neil Armstrong, obviously, on the moon with Apollo 11. And then it kind of all fizzled out in the 70s, and it's been a long time since we've bothered going back there, because the kind of original purpose for doing it, which was that space race, that kind of power dynamic, had fizzled out, really. So now we're going back, or trying to, hopefully landing people back on the moon, so that space can be explored a little bit more from a potential moon base that might be there. But of course, it's a little bit more than that, Becky, because there's a feeling that there's some money to be made from the moon economy, believe it or not. So there's always dollar signs somewhere, isn't there? So there's a feeling that for various reasons, there's money to be made by going back to the moon. So that's where we're going. And hopefully there will be a long-term presence then on the moon. So I think landing on the moon is scheduled for 2028, I think. So that'll be one to follow with children at school and things. That'll be exciting. But I was just comparing and contrasting the two programs, Apollo and Artemis, a little bit. So the very early, so before Apollo, there was the Freedom program as well. And pretty much all of the calculations needed to get a rocket into space at that point were done by hand. And even with Apollo, it was done by very basic computers, very, very early computers. And so there was a real reliance on mathematicians like Katherine Johnson to make sure that these figures that the computers were spitting out were accurate, really, because obviously the consequences of them not being accurate were disastrous. Either you're not going to get to where you're going to, you won't be able to get back from where you're going to, or disaster, leaving or re-entering. Incredibly dangerous stuff. Whereas now everything is done with really powerful computers, advanced simulations, AI is involved, believe it or not. It's everywhere now, isn't it? But underpinning it all, it's the same maths. It's exactly the same maths, the same calculations, just different ways of doing them. So, the tools have changed over that time, but the maths haven't. We know that our smartphones that we've got now are way more powerful, millions of times potentially more powerful than the computers that they had on the Apollo rockets and things. But it still has to do the same calculations. So, I thought that was interesting. And the things that have stayed the same, obviously the trajectories, which are the curved paths that you have to take under under gravity to work out, the right path to take to leave the Earth without disappearing off into the void, so that you stay within Earth's gravity, but don't disappear out of it or crash back down to the ground. And the other part of the trajectory, obviously, to get to the moon, get caught by the moon's gravity so that it pulls you close enough to the moon, but then spits you back out on the other side. I mean, that is the maths involved in that. I can't even begin to
No,
comprehend, really.
the exactness of those calculations must be, it must be
Yeah.
pretty exact, mustn't it? It is amazing.
But underpinning it all is the same stuff that we teach in primary school. It's the same numbers, the same multipliers, the same calculations. It's the same thing, really, just more complex, obviously, because you've got all the physics involved in it as well. So I did want to talk a little bit about Katherine Johnson, if that's okay, because I think it's an important part of maths history, really, and you know that we love a little bit of maths history on the podcast, Becky. So Katherine Johnson was born in August. She was a summer baby, just like me, Becky, and you. Are you a summer baby?
I'm a spring baby.
Oh, are you? Sorry. I got it in my head that you were an August baby as well. Held both me and Katherine back all our lives, obviously being born born in the summer, youngest in the year. That's kind of where the similarities between me and Katherine end, though, particularly in terms of achievements. So she was born as Creola Katherine Coleman, and she was the youngest of 4 children. And right from an early age, it was kind of recognised that she had this fantastic mind, particularly for maths. But unfortunately, she was living at a time where public schools in her area in the United States, where she was born, didn't offer places to African American students after the 8th grade, age 13. So that's where her story could have ended because of these, the discrimination that was around at the time. Fortunately for Katherine, and fortunately for space travel, her parents arranged for their children to attend a school in a different county. So I'm not sure whether they travelled there each day or whether the whole family moved, but yeah, so she moved. She didn't move at 13, though. She moved to high school at the age of 10 because she was so far advanced. And she graduated from high school at 14. And then she went to university, where she obtained a PhD at West Virginia State University in mathematics. And then do you know what she went on to do after that, Becky?
Well, did she teach?
Yeah, she became a teacher, as all the best people do. She became a teacher, and she taught at a African American public school in Virginia, because at that time, again in the 1930s, she wasn't allowed to teach in any other schools. I mean, maybe that wasn't the only reason that she taught in that particular school, but her options were limited. But I was thinking about this because we come across people sometimes, don't we, where sometimes parents push for their children to be in a different year group or feel that they should be doing more advanced maths than the rest of the children. Perhaps I remember having a conversation with a parent a few years ago who felt that her son was gifted in maths, and to be fair, he probably was, and felt that he wasn't, necessarily being stretched enough by the maths that we were doing in the classroom at the time. And I suppose that's, we think about that in terms of adaptive teaching now, wouldn't we? I'm not sure that we would necessarily be very rare for a child to be sitting their GCSEs several years earlier than usual. Yeah. But, still important that within our approach that we have in classrooms, that we are catering for those children who might grasp things a little bit more quickly. In fact, thinking about our approach within Planet Maths, the updated scheme that we have at Twinkle, we've tried to make sure that there are challenges for everybody to access, but throughout the lesson, so that if you have children who are, maybe grasping it a little bit quicker, maybe previously high retaining, maybe have already done some of this in their own spare time for fun, which is wonderful. There are opportunities for them to think a little bit more deeply in that. And I think that's a really good way of approaching it.
Yeah, it's about that meaningful challenge, isn't it? Making sure that the challenge is, you're not filling time, but you're actually extending understanding in some way. But yeah, that's definitely something that we've thought about a lot during the development of the new scheme.
Absolutely. So in 1953, Katherine Johnson joined the National Advisory Committee for Aeronautics, the NACA, where she was essentially what was known as a computer. She performed mathematical calculations. Now you think about the word computer, it's computing, it's doing calculations, basically, along with several other women, some African-American women as well, who were employed to do this. Now, the NACA would later become, Becky, can you guess? Yes, so doesn't really share, even though it's only one letter out, doesn't really share many of the same abbreviations, but national, I suppose, is the same. National Aeronautics and Space Administration, NASA. And she was assigned there to analyze data from test flights to help the flight research team. And in 1961, she calculated the trajectory for Freedom 7, which sent the first American man into space. So, yeah, before even rudimentary computers were being used to do this, it was done by hand. And that man was a chap called Alan Shepard. And not only did it help him get into space, it also meant that when he returned, which he did, thankfully, they could coordinate where he was quite quickly, because, I often think this about sci-fi shows and things, Becky. I don't know if this has ever crossed your mind. When, say, Star Trek or Star Wars or whatever, go to a new planet, they always seem to go to a town or a city that seems to represent the entirety of that planet and the entire civilization. It'd be like somebody going to, I don't know, from Star Trek, an alien coming and visiting Nottingham and that representing the whole of the planet or something.
Yeah, good point.
Yeah, it crosses my mind now and again. These 3 o'clock in the morning. So finding somebody who's landed on a planet and an entire planet can be quite tricky. So making sure you got the calculations right is really important. So she did that really well, and obviously was kept on. They found Alan Shepard, which was good news, particularly for Alan Shepard. And then when electronic computers were introduced, there was quite a bit of skepticism around them. And a famous astronaut, John Glenn, who later was part of the Apollo missions as well, refused to fly in the 1962 Friendship 7 mission unless Johnson had checked the calculations herself that the computer had done. So, that was... she was held in high regard for that. So much so that she was later called upon to help calculate the trajectory for the 1969 Apollo 11 mission, which obviously led to the first man walking on the moon. So a remarkable lifetime of achievements, really. And she was with us until 2020. So she lived a long life. She co-authored 26 scientific papers in that time, and she received the Presidential Medal of Freedom in 2015. And I love this, Becky. She also received the Silver Snoopy Award, which apparently is a special honor for outstanding NASA employees in 2016. So yeah, what a remarkable person, what a remarkable woman. The adversity that she had to overcome to make her mark in the history books, but she really did.
It's an amazing story of perseverance and resilience, isn't it? I don't know if you've seen the film Hidden Figures, but
No.
Well, it outlines, it's not just the work of her, but some other women as well in the NASA program. But it's all about, you'd love it, John, after this conversation. But it outlines the struggles they had. Just amazing.
Well, I will look out for that, Becky, because it does. It sounds like it's right up my street, actually. But yeah, all of that information, by the way, I took from a fact file all about Katherine Johnson, which you can find on the Twinkle website if you have a Twinkle subscription. There's all sorts of resources actually on the website. all around Katherine Johnson, which I just thought was helpful, really. An easy place to find them.
Yeah, absolutely. Katherine Johnson has also been the inspiration for one of our upcoming characters for some new content that we're going to be talking about next week, Jon.
Wonderful. Yeah, I'm looking forward to that, Becky. So we will leave it there, I think, for today. However, one thing that I would like to flag up, if you're listening to this on Friday the 17th of April, which is when it's released, and if you're not, why not? On Tuesday, Becky, we have our first problem-solving Teach Meet, don't we? Which is some free training, which you can sign up for, absolutely free. We'll put the link in the show notes to this. Come along and join us. It'll be Becky and myself. Thinking, well, what's the topic for this one, Becky? Do you want to tell us a bit about it?
The focus for this Teach Meet, so we have a new collection coming out, Jon, which we'll talk about next week, where we're talking specifically about the strategies involved in problem solving and how to teach them. So we're starting by looking at the power of pattern spotting is our first one.
Fantastic. I'm looking forward to it. Love a little bit of pattern spotting. So yeah, come and join us for that. We'll put the link in the show notes for this. It's totally free. And you can come and listen to Becky and I talk about pattern spotting a little bit and ask any questions that you might have as well. I will be back on Tuesday, not just for the Teach Meet, but also for another interview episode. If you missed this week's interview episode, it was all around financial literacy with Dr. Paula Fieldhouse, and it was a fantastic listen if you are interested in that at all. Not just financial literacy, also engaging with parents actually as well, and the role that they might have in children's mathematical journeys. So go back and have a listen to that one if you missed it. On Tuesday, I'm going to be talking with Kate Henshaw all about making maths purposeful and how to get children thinking mathematically. So join us for that one if you can on Tuesday. Otherwise, Becky, I think we'll leave it there for today.
That's it, Jon. Thank you. Thank you for joining us, and we'll see you next time.
Yeah, thank you so much for joining us. Have a great week. We'll see you then.